Our next set of directions are going to be to rationalize the numerator. Now, I want to take a moment to point out that this kind of goes against our whole motivation behind why we want to do this in the first place. I'm not going to give you a ton of work when it comes to rationalizing numerators, but I do want to talk about it briefly just because it does come up sometimes when you're dealing with trigonometry, for instance. There's times that we want to say, let's get the radical out of the top and into the bottom to see if we can recognize it to be similar to one that we've seen before. So, with that said, let's go ahead and look at two examples. One in which we have a single radical in the top that we want to get rid of, and one in which we have a single radical in the bottom that we want to get rid of. Or sorry, one in which we have two terms in the top that we want to get rid of. And we're basically going to handle this just like rationalizing denominators. The only difference is we're going to look at the top. Now, for the first example, the first thing I would actually do there is I would simplify this whole fraction. Because with 32 over 80, there's a 16 that goes into both of those. So really that root 16 or 4 goes away, and it's just root 2 over 5. So that's always something to look for when we're trying to rationalize either numerators or denominators. Now, since our goal in this problem is to rationalize the numerator, we want to multiply by whatever it takes in the top to bring it up to a perfect square. So that's going to be root 2 over root 2. That's going to get us 2 in the top, root 10 in the bottom, and that's actually the answer for rationalizing the numerator. Now, for our other example that had two terms in the numerator, like we did with denominators, in order to rationalize this, we're going to multiply by the conjugate. So we're going to multiply by root x plus 3 in the top and the bottom. So that up top, that's a difference of squares. We're going to have root x squared is x, minus 3 squared is 9 in the top. And in the bottom, we're just going to distribute that 4 across. And so I know I kind of rushed through this a little bit, but honestly, we're not going to do a whole lot with rationalizing numerators, and it should be fairly straightforward and simple, that you basically do the same thing as what you would have done with denominators, you just do it to the numerator instead. So there you go.